integrated late rows. So far we've talked about the differential late rows, and just reminder of some of the late rows that you need to have in mind. Um, our rate being equal to k, and then we can have our rate being equal to k a b, or maybe I can just put a to the power 1, and then we can have a 1 b 1. So the other form of the second one would be where it is only a single what? A single reactant to the power 2. So we've got what we call reaction orders, and I said that the overall reaction order is determined by adding the powers of the orders of each reactant. Okay, so the first one, you can notice that it can actually reduce to just k, so that one is called the zero order reaction. Okay, so in a zero order reaction, since the rate is equal to k, the units of the rate and k are the same, and then in this kind of a case, the units of k is also molar per second. And then the other thing that you need to note is the rate of the reaction is independent of the concentration of the reactants. And then in this other case, the rate is only dependent on a single reactant. Even if there are two, only dependent on a single reactant. Okay, usually common in the composition reactions where you only have a single reactant, but even in some cases where you've got more than two reactants, the reactions may still be dependent on a single reactant to the power 1. So these are called phased order reaction. For the last two, if I look at this one, if you add the powers 1 plus 1, we'll have the second order reaction. So sometimes it may be as I've indicated 2, or sometimes just a single reactant to the power 2. So they are both examples of second order reaction. So as we look at the integrated late rows within our scope, we are going to talk about the zero, phased, and second order reactions. Okay, so now what are the integrated late rows? So integrated late rows, as the name entails, are determined after integrating the differential late rows that we basically get. So why are they called differential late rows? For example, where we started with our reactants A plus B giving us C and D, right? So I said taking our stoichiometric coefficients to be their small letters, if we're talking about the rate, for example, in terms of A, it would be negative 1 over A, change in the concentration of A divided by the change in time. So you understand from calculus that delta, change in y over change in x, is a derivative. Okay, that is differential. You're looking at the difference. Okay, the rate of change. The rate of change is a derivative. Okay, now let's talk about the integrated late row. So I've already given you an example of the late row where you have a zero order reaction. So I'll start with a zero order reaction. Zero order reaction. So I'll just combine them so that you basically get everything together. First and second. Okay, so these equations are very easy for you to basically get to remember. Okay, so what have I said? I've given you an example to say in a zero order reaction, the rate of the reaction is only equal to k. If there is a reactant there, then it's the power 0. Okay, so I've made a very important statement to say in such a case the rate of the reaction is independent of the reactant. So the actual equation for the integrated late row, or the integrated late row for a zero order reaction, becomes the final concentration being equal to negative k of t plus the initial concentration. Of course, this makes more sense if you start with the initial concentration and then subtract kt. This tells you that after as time progresses, you expect that the amount of what you had started with initially is going to reduce in terms of k and also how long it has taken. Okay. Now for the first order, I like relating it to the first one because if I'm able to remember the first one, it's going to be actually easier for me to remember the second one. In a way that the first, we only introduce the natural log to the parts where we have the concentration. So we'll have natural log of the final concentration being equal to negative kt and then plus natural log of, so I've said we're only introducing the natural log to the parts where we have the concentrations, that part and that part. That's what makes the difference between the first order and the zero order reaction. Of course, an example of the electro here is where it's only dependent on a single reactor and raised to the power 1. Now for the other one, we have of course two examples of the the electrodes. A case where you've got two reactants raised to the power 1s, or a case where you only have a single one to the order 2. So here the electro is the first one, but here we put the fractions. So it is 1 over the final concentration being equal to, and what makes it unique is here the gradient part is positive. So kt plus 1 over the initial concentration. So I've related the last two, first and second, in comparison to the first one. Converting the zero order reaction to the first order, you only introduce a natural log. Converting it to the second order, you put the reciprocals of the concentrations, and then don't forget that the kt is positive for the second order reaction. So these are actually the integrated load flows for the zero first and second order reaction. So you're able to make some observations by just looking at them as they are given. Hopefully you are able to remember them. Now I need to mention to say these have got certain graphs that you need to expect. There may be some cases where they ask you to plot on a graph and ask you to tell the the order of the reaction. Okay. So we'll take something as, let me just draw all the graphs at the same time so that you're able to compare them and make sense out of them. So you can have something like that and something like that. You can have something there, something like that. Then we can have something here and something like that. So what we need to expect is something like this. Now you should be able to guess already which ones are. So the ones that are going down tells you that the gradient is a negative, and you're able to tell that it was a 0 and the first, where we saw the negative kt being negative. Okay, so of course what matters or what differentiates them is what you put on the left, on the x, on the axis. So for the y-axis, we're going to use for the first order, for the zero order reaction, we're just going to use a concentration there. So the concentration of A, let me use something different so that you can see clearly. So the concentration of A, okay, and then for the first order we'll use the natural log of the concentration, and then for the other one it will be 1 over the concentration. So here we expect to have time. So the basic idea is, if I give you the graphs and then you try to observe them and then you try to notice which one is giving you a straight line. Is it when you plot natural log against the time, or is it when you plot just the concentration against time, and so on and so forth? So the basic idea is, if you are to plot the concentration against the time and then it gives you a curve like this, then just know that it is the statement you can already make from that is, it is not a zero order reaction because it is curved. It's supposed to be a straight line downwards. Now if you come up with coordinates where you say, okay, let me try out my natural log of the concentrations that have been given, and then you come up with the table of values, determine the natural log of all the concentration values you've been given, and then with time, if you get to plot the graph and then it gets to go downwards as a straight line, that is proof enough to say it is a first order reaction. And then obviously for the last one, this one is unique in a sense that it's the only one that goes upwards. So if it goes upwards straight like that, when you determine again 1 over the concentrations given against the time as your table of values, you try to determine the values. If it goes upwards straight, just know that this is a second order reaction. Okay, very important, very important. So these graphs are very easy for you to remember by just looking at the gradients there. Okay, and what you need. So these are actually what are determining on what you should use when you want to try test, especially in the case where they give you data about the concentrations and then the time. Okay, so what I'm trying to say is, the data you expect to be given is they give you the concentration of A and then they give you the time. So if they ask you to say, is it a second order reaction, is it a second order reaction, and then you want to graph. So if you're trying to test whether it is a second order, you'd have of course use that. So you'd have to now convert the concentration values you've been given into 1 over the concentration, and then you plot that against the time. If you're doing it with the first order or the same, again you apply the same concept. Okay, so let's proceed now and just get to talk about the half-life. Oh, why am I saying the half-life? So before we talk about the half-life, let's talk about the some few practice questions just now, to just make sure that we solidify whatever we've gathered. Yeah, so that part will go and edit it to just get a few of what we do when we are making videos behind the scenes. Okay, so in the first order decomposition of dinitrogen pentoxide at 335 Kelvin, this is the equation that we have. If we start with a 2.50 grams, so already that is the initial, and then 1.5 grams, so that is the final after 109 seconds. The first question is, what is the value of the rate constant K? So each time they tell you the order of the reaction, the first thing that you need to remember is remember the equation. So are you able to remember the equation of the first order reaction? Okay, so if you're able to remember for a zero order reaction, it is only the concentration equal to negative KT plus the final plus the initial. Okay, we are seeing a difference. Now for the first order, you introduce the natural log. So it's a natural log of the final concentration. Okay, and then the negative KT, which shows that there's a decrease in the starting concentration. So natural log of the initial concentration. Okay, so let's try to identify the piece of data we've been given. So I can see we've already identified, we've been given the initial there, and then we are also given the final. Okay, of course in terms of mass, that will still apply the same concepts. So we've got the final and the initial, available. So final is available, initial is available, time has been given as well, so we're able to find the value of K. There's no need of us to convert the grams to molar concentration, it will still be the same. So take the values as they are and plug it into the equation. So the natural log of the final concentration, which was, we are told it was 1.50 after 109 seconds, and then negative kt, our time was 109 seconds, and then plus natural log of the initial concentration, which was a 2.50. So I can take out on the other side, so that it becomes the difference between 1.50 and then 2.50. Of course, that becomes negative 109k. And then you can just punch what is on the left. Of course, logarithms tells us if you want, you can just divide the values and then compute a common natural log on the two values. Okay. So I'll say my natural log of 1.50 minus my natural log of 2.50. So I'm getting a negative 0.5108. So obviously if you want to find the value of k, we would have to divide by the 109, the negative 109 on the other side. So negative 109. So the answer becomes a positive value, where now our k becomes equal to 0.00469. So that is the value of our constant k. So if this is a first order reaction, so I gave you a short formula. If you've not taken out of the units as you are calculating, the short formula is 1 minus n, a second negative, where n is the overall order of the reaction. So if a first order, you plug in a 1 there, the units will just be a second negative. B, I'll skip it. We've not yet talked about the half-life, but we'll begin with this question as we look at the half-life just in a while, in a little while. What mass of that will remain after 5 minutes? Okay, so we need to determine how much will remain after. So our k is in seconds, so we'll have to take note that we'll work with time in seconds. Now using the value of k and then using our initial concentration. So natural log of the final concentration is equal to negative kt plus natural log of the initial concentration. So for any information, with the help of logarithms, I can just combine these on one side, on the right hand side, by making a combination to say if this one goes the other side, if this one goes the other side, it becomes a negative. So subtracting logarithms is as good as combining the natural log, since they have got the same base, so that you say it's final over the initial equal to negative kt. Of course, if you want, you can just handle it by just substituting in the equation. There's still no harm. So natural log of the final concentration was what? That's what we want to find. So in this case, this formula doesn't become probable because we don't have a value of the final concentration. So therefore just continue as we are. Natural log of the final concentration is equal to our k has been calculated there. So we have negative 0.00469. Our time, 5 minutes, need to go to seconds. So we know in a minute that's 60 seconds. And then plus natural log of the initial concentration, which was a 2.50. Okay, so you'd have to be very, very careful with the question, what the question is asking you to do. So obviously in this case, there's been no specification on where the time is coming from. So obviously we are taking it from the start. So natural log of our final concentration is equal to So let's punch what is on the right on the calculator. Right answer, it becomes negative 0.490709. Now if we're to find the concentration according to logs, natural log has got a base of E there. So our final concentration becomes E to the answer we have. So if you've done logarithms, you realize that if you've got log with a base 10, the value of x being equal to 2 there, the value of x is going to be the base of 10 will go the other side, so what is on the other side becomes the power of the exponent. So now the question is, what is e to the value we have there? So I'm getting 0.6123 grams. So of course I can just round it off to 0.61 grams. So that is basically what we're expected of from this question. So let's look at the other question. Are you enjoying this video lesson? So you can actually access the entire topic you're watching or the entire practice questions of a video that you may be watching right now. So if you go to our website is transcendedinstitute.net. Okay, so there are 3 ways that you can access our videos. So you can use Patreon, you can use channel memberships. If you're in a country where it's allowed, you'll be able to access our full topic videos and full practice questions. So alternatively, you can access the videos using our learning portal. The link is learn.transcendedinstitute.net. So I'll show you a few videos that you can have access to after registering. So for example, if you had to open mathematics as at now, these topics are the ones that are available, which you can learn from scratch. I can just give you an idea of, so you like learn everything from scratch, meaning that even if you're learning something for the first time, these videos are there to help you with concepts as well as practice questions. So for example, these are tutorial sheet solutions from different tutorial sheets, which can help you as well get to learn faster and remember. So binomial as well, there it is. And of course this applies to all these other topics that are available, trigonometry as well, calculus, depending on the topic that you're interested in mathematics. So you can just head over to the site at now to check what is currently available. Even without registering, you should be able to see the content in each topic. So let's assume you're interested in physics. These are the topics available as at now. So if you open chemistry, these are the topics available as at now: electrochemistry, stoichiometry, thermochemistry, kinetics, equilibrium, solubility, equilibrium, atomic structure. So trust me, if you open these videos, you might have learned the topic in full. Let me show you stoichiometry. So stoichiometry, we have all the way up to 21 videos, including the tutorial sheet solutions, which will help you to practice both the concepts and also prepare for questions. Okay, so feel free to head over to the site and check out these videos on your own. So equally biology videos are also available, which you can also basically get to access. So these are the topics available so far. Yeah, so pretty much these are the ways you can easily access our full membership videos that you don't have access to on the channel. A flask that initially contains 0.056 molar concentration of nitrogen dioxide. So we can identify that to be our initial concentration. What will be the concentration after 1 hour? So that's our time. Now we've also been told if the reaction is second order. So a second order reaction, are you able to remember the equation? So this is where we introduce the reciprocals to the concentrations. So final is equal to Kt. This is where we've got the positive gradient and then 1 over the initial concentration. So that's the first part of the question that we need to answer. Before we answer the other one, how long it will take for the concentration to decrease to 10% of the initial. The value of K has been given to us. So straight away, we'll take the final, which is the unknown there. We'll take it as x. So say 1 over x is equal to, our constant is 0.54. So the units are of course molar negative, second negative. Our time, which is given as an hour, has to be converted to seconds because our k is in seconds. So in a minute we've got 60 seconds. Now in an hour you've got 60 minutes. Okay, so 60 times 63,600 seconds a in an hour. So plus 1 over the initial concentration, which was 0.056 molar concentration. 1 over x is equal to, so let's try to compute what we have on our right hand side there. So the value I'm getting is a bit like 1.961.85. Okay, we'll take that 7. So if we cross and multiply there, first to find the value of x, it will be 1 over 1961.85. Of course that is a comma there. So 5 7, 1 divided by that, your answer becomes 0.005,097. Okay, now that is our concentration. So what is our concentration after that? After that time had elapsed. If you want to take it to standard form, 1 2 3 4 5.097 times 10 to the power negative 4 molar concentration. The question continues to say, how long will it take for the concentration to decrease to 10% of the initial concentration? So this question is just direct, so just find the 10%. So 10% is just 10 over 100 multiplied by the initial 0.056. So that will be taken as your final concentration. So 10 divided by 100 multiplied by 0.056. So it becomes 0.0056 molar concentration. So how long will it take for the concentration to decrease to 10% of the initial? So this is the 10%. So how long is it going to take for the concentration to reduce from 0.056 to this value? That's what the question is asking. So at least it becomes a bit tricky where they say, how long will it take for the concentration to decrease by 10%? In such a case, you determine the 10% and then subtract it from the initial and take it as your final. But in this case, this is direct. 10% you find is the final concentration. So we'll plug in into the formula. 1 over the final concentration, which we want 0.056, the computed 10%, and then equal to kt, our k is 0.54, and then we have a time plus 1 over the initial itself, 0.056. So this is simple and straightforward. We can compute. So 1 divided by 0.0056. Okay, so we'll have something like 178.571 on the other side. So I can just take this on the other side directly. So say minus 1 over 0.056 equal to 0.54 t. So let's subtract that value, 1 over 0.056. So the difference becomes 160.714. So we need to divide by 0.54. So divided by 0.54. So the time becomes 297.6 seconds. Okay. So that is basically our expected solution there. So this is an introduction to the integrated electrodes. We'll now continue and just talk about the cases where we involve now the half-life of the integrated electrodes. Are you enjoying this video lesson? So you can actually access the entire topic you are watching or the entire practice questions of a video that you may be watching right now. So for example, if you get to check right now, these are 4 videos which shows member only content. So for example, this trigonometric tutorial sheet is like 5 hours 48 minutes. There are other tutorial sheet solutions and other topic videos available fully here. You can see the hours that they are. So on YouTube, the ones that are available for free, just like maybe half of that, or even just a third of the total time. All these tutorial sheets, you have access to them. So this is actually available in all the courses. For example, you can see chemistry as well, stoichiometry 4 hours, atomic structure. So these videos, you can access them in 3 different ways that I'm going to show you. So if you go to our website is transcendedinstitute.net. Okay, so that's our website. So this is the what we do. Of course, Transcended Institute, we just make tutorial videos. So depending on your location, there are 3 ways that you can access our videos. So you can use Patreon, you can use channel memberships. If you're in a country where it's allowed, you'll be able to access our full topic videos and full practice questions. Okay, so you can also download our mobile app. The link is here. If you're on Android, I believe by the time you may be watching this video, even the iOS app may also be available. Okay, so alternatively, you can access the videos using our learning portal. The link is learn.transcendedinstitute.net. So I'll show you a few videos that you can have access to after registering. So for example, if you had to open mathematics as at now, these topics are the ones that are available, which you can learn from scratch. I can just give you an idea of, so you like learn everything from scratch, meaning that even if you're learning something for the first time, these videos are there to help you with concepts as well as practice questions. So for example, these are tutorial sheet solutions from different tutorial sheets which can help you as well get to learn faster and remember. So binomial as well, there it is. And of course this applies to all these other topics that are available, trigonometry as well, calculus, depending on the topic that you're interested in mathematics. So you can just head over to the site at now to check what is currently available. Even without registering, you should be able to see the content in each topic. So let's assume you're interested in physics. These are the topics available as at now. So you can actually just head to the site to check the topics that are available at the time you're watching the video. So for example, I can show you work. These are videos available explaining work, including the tutorial sheet based on work. Okay, let's say you're interested in circular motion. These are the videos available on circular motion with tutorial sheet solutions. Linear momentum. So if you watch these videos, trust me, you should have understood the topic in full. For example, momentum, this is what you get to learn. Check the length of the videos and I mean they are. And then I can show you now a bit of some chemistry. So if you open chemistry, these are the topics available as at now: electrochemistry, stoichiometry, thermochemistry, kinetics, equilibrium, solubility, equilibrium, atomic structure. So trust me, if you open these videos, you might have learned the topic in full. Let me show you stoichiometry. So stoichiometry, we have all the way up to 21 videos, including the tutorial sheet solutions, which will help you to practice both the concepts and also prepare for questions. Okay, so feel free to head over to the site and check out these videos on your own. So equally biology videos are also available, which you can also basically get to access. So these are the topics available so far. Yeah, so pretty much These are the ways you can easily access our full membership videos that you don't have access to on the channel.